Welcome back to Water Quality in the Pacific Northwest. Today we start our last set of units, and the title of this unit is Waste and Trash. So we'll continue to talk about water quality and pollution. The components of these last three units include wastewater treatment, septic systems, and solid waste. It's important that when we get rid of our liquid and our solid waste that we do not pollute waters. So we're going to start off with wastewater treatment, lecture number 38. A couple definitions very quickly. I will interchangeably use the word sewage and wastewater. And this name change or morphing in the name of wastewater is simply because the government around the world prefer wastewater treatment, feeling that wastewater treatment as a term is more acceptable to the public than sewage. So what's the problem with wastewater? Let's talk about wastewater handling first of all. There are health hazards associated with wastewater. Untreated wastewater or untreated sewage is a major health hazard because if it comes back into contact with humans before it's treated, it may contain pathogens and thus it may be a vector in the spread of many diseases. Traditionally, it has been pretty common to see a lot of human liquid waste just dumped directly into water bodies. This particular picture here is typical of what was happening in the 50s, 60s, and 70s in the United States. Since the Clean Water Act was passed, however, it became important to treat wastewater. And remember, the biggest problem with wastewater that humans generate is that it is a vector in the spread of many diseases. Diseases including typhoid fever, cholera, different types of salmonella, diarrhea, infectious hepatitis, dysentery, giardia, roundworms, and flatworms. All sorts of vectors can be found in untreated wastewater, and these pathogens can be transferred directly to humans. For instance, looking under a microscope, untreated sewage, this comes from South America. You see a roundworm in here. That roundworm can get in human beings and cause a lot of problems. So we have to take a look at the relationship between untreated wastewater and human disease because it's been a very important relationship throughout history. So let's start out with a sick person. A sick person sitting here, he's not smiling very much. The sick person is always drinking water, eating food, and that sick person excretes their waste. If that waste that the sick person excretes ends up in the water source for the next person down the road, so you have a sick person evacuating liquid waste from them that is contaminated with pathogens. Those pathogens get into the drinking water for the next person down the line. All of a sudden, that person in the middle, that second person, becomes an unhappy person because they get sick. So it took centuries, up until the late 1880s, that science recognized that we have to cut this link right here between the first sick person and the next consumer. And that's why we treat wastewater, so that we can get rid of the pathogens and that other people do not become sick. Traditionally, this is what happened in the Middle Ages in cities all over Europe and all over the world. Lots of people were sick all the time because they were getting sick from diseases spread by sick people. So we handle wastewater primarily to get rid of pathogens. When an area is not very heavily populated, when the host population of humans is sparse, there's little transfer of pathogens. And that's because the contamination levels are relatively low. Conversely, when we get into cities and towns, we have populations of potential hosts being pretty high. A lot of pathogen transfer can occur because the contamination levels are initially pretty high. So remember, we go back before the 1880s, there was not a connection between sewage or human wastewater and disease. Before this connection between sewage and disease in humans was made, epidemics were common in many major cities of the world. If we look around the world today, in places where we still don't treat our sewage, there is still a potential for major epidemics. For instance, if we have an earthquake in a middle or a less developed country, lots of times the pipelines, the water pipelines are broken and they get contaminated with sewage, and then we all of a sudden have a major epidemic, such as cholera breaks out. U.S. tourists that go to third world countries, they're told to be really careful with the liquid they consume. Probably they should boil their water or drink bottled beverages because there is a low level of pathogens in that water in many third world countries. So let's take a look at the historical handling of wastewater. If we start out with the historical background, in the United States, prior to 1900, it was common to not have bathrooms in homes. People had an outhouse associated with their living space, and the waste was generated in the outhouse, and that outhouse was connected to a water body, probably a river, so nothing was treated. So here's the old traditional outhouse. As we started to realize the connection between untreated wastewater and health problems, we moved away from outhouses to indoor plumbing, and we moved to flush toilets that were connected to sewers. However, these flush toilets were connected to sewers that were connected directly to rivers, so the untreated waste was dumped directly into rivers, and you saw pictures like this along rivers in many cities of the country. So as we tried to improve sanitation by moving to flush toilets in the home connected to pipes that went into sewers, basically we dumped the untreated waste directly into rivers, and the rivers basically became open sewers that had large concentrations of pathogens. Now, this became a problem as the country grew, populations became more dense, and as a consequence, in the late 1910s, wastewater treatment was initiated to try and clean up polluted rivers and to protect human health. Actually, the first wastewater treatment plants in the United States were built in about the year 1900. Older cities had two systems. They had sewers and they had storm drains, and in many old cities, the sewers and the storm drains took water to one treatment plant. When conditions were relatively dry, this was not that much of a problem. However, when the weather was wet, the amount of water going into storm sewers overwhelmed the wastewater treatment plants, and basically you weren't able to treat all the water that had pathogens in it. So we had storm drains for precipitation runoff, and nowadays most cities have their storm drains that come off our city streets, go directly into rivers, and wastewater that comes out of sewers go to the wastewater treatment plant. So here's a picture of a storm sewer, basically carrying water off the surface of land in cities. Now, it doesn't work really well when you have storm sewers and regular sewers from homes on the same system, and that's because of peak flows. When there's a storm, there's a lot more water in the system, and it overwhelmed the wastewater treatment plants. Because of this, most cities have moved to a dual system where we have storm drains that take care of the precipitation runoff. A lot of times that water isn't treated, it's directly put into the river. And then we had sanitary sewers to take the liquid waste out of homes, offices, industrial areas. So today, the water that goes down our drains in our home goes into sanitary sewers that go to wastewater treatment plants. And here's an overview of a modern wastewater treatment plants, and that's what we're going to talk about primarily in the lecture today. So let's take a look at wastewater handling. We're basically talking about wastewater coming out of our homes that go into our sanitary sewers that end up in our wastewater treatment plants. In highly developed countries such as the United States, Western Europe, Japan, the situation is under control. We have wastewater treatment plants that treat well over 90% of the liquid waste that we generate in our homes. On the other hand, wastewater handling is a mess in less developed countries. Many large cities in less developed countries do not have the sewer capacity to treat all wastewater. And as a result, we see pictures of kids basically playing in open sewers in their hometowns. Here's an example in a third world country where kids are outside playing, having a good time, but if you take a look at the water there, that's basically liquid waste, stagnant with pathogens, and not a good situation. It will cause a lot of disease and a lot of problems with public health. So in these situations in less developed countries today, where you have open sewers, you have a situation that's ideal for disease transmission. Now, over time, the locals living in these less developed countries pick up a little bit of immunity from some of these pathogens because they're repeatedly exposed to these pathogens. So the locals pick up some degree of immunity, not total immunity. A lot of times people are sick at a low level. However, a visitor from a highly developed country coming into this type of situation can easily get sick if they drink the water. So remember, in less developed countries, visitors do not have the immunity that locals have developed to some of these pathogens in the sewage. Consequently, it's recommended that visitors from highly developed countries drink bottled water or boil their water. Okay, let's take a look at some of the materials that go down our drain in our homes and end up in a wastewater treatment plant. We call the material or the liquid that flows down our drains in our home raw sewage. Raw sewage is basically water with a little bit of waste. Raw sewage is primarily water, 99.9% or more water, and about 0.1% waste, or about 1,000 parts water to 1 part waste. Pretty diluted. A lot of people have done studies looking at the composition of sewage that goes to wastewater treatment plants. Here's an example of the sewage. Basically, this type of sewage, remember, it's only 0.1% waste. The rest of it is water. There's a little bit of hazardous material, a little bit of wood, some rubble, some glass, plastics, sanitary napkins, little shreds of paper, a lot of organic materials. So we know a lot about the composition of raw sewage. So raw sewage is 99.9% water, only 0.1% waste, or 1,000 parts water to 1% waste. If storm water were all added to this mix, you get an even more dilution. So raw sewage becomes even a higher percent wastewater. So modern cities have what we call wastewater treatment plants that clean up the water before it goes back into a water body. The water that's coming out of our homes goes down the sewer, it goes to a wastewater treatment plant, and there are several steps to clean up that water, such that by the end of treatment, that water flowing back into a river or a water body is clean or relatively clean, but it is also pathogen free. Now we can divide that liquid waste or that raw sewage into 4 distinct categories, and that's what we're going to talk about primarily in this lecture. The first category we're going to say is, remember, that's 0.1% of the liquid waste is basically not water. The raw sewage would include what we call debris and grit. These are larger sized particles. The debris would be little pieces of rags, some bags, a little bit of plastic that went down a person's drain, and grit, things like gravels and coarse sands that went down a drain in a home. Now, if we take a look at wastewater treatment steps, raw sewage comes to a wastewater treatment plant, and then it moves through what we call a bar screen. And this is a screen that has bars that are about 1 inch apart. The water flows through this screen, and basically what the screen does, it will remove any of these large inert particles, the debris and grit. It will prevent them from going to further steps in the wastewater treatment plant. We call this removal of the debris and grit a preliminary treatment. So here's an example of preliminary treatment in a wastewater treatment plant. We have the line, the sewer line, sanitary sewer line coming in from the community. The wastewater moves through this screen. This screen, this 1 inch bar screen, anything that is debris or grit that's larger than 1 inch in diameter will be removed in this process. And then this debris and grit is scraped off and it's disposed of. The debris and grit, the things that are smaller than 1 inch will go into what we call a grit settling tank, and that will allow gravity to settle out these larger particles. We call this preliminary treatment. It's the first thing that happens in a wastewater treatment plant. We rely on gravity, basically physical processes and gravity, to remove our debris and grit. Again, another picture, wastewater flowing in the pipe into the wastewater treatment plant, which starts right here. We have the bar screen. It removes the large debris and grit. Then we have what we call a grit settling tank, and gravity moves the larger particles down to the bottom of the tank, and then we can remove that material through gravity and then dispose of it. We can incinerate it, we can landfill it, we can do a lot of things. Looking at preliminary treatment a little bit differently, here's another diagram. Basically, here's the pipe up here. It's entering the wastewater treatment plant. It goes through the bar screen, it goes through the grit settling tank, and basically the solid objects that are fairly heavy are removed because of gravity to the bottom. They're removed and they're disposed of. So that's step 1. Now step 2, we're starting to look at smaller particles. We remove, in step 2 of a wastewater treatment plant, we remove what we call the particulate organic material. This is organic material that we can see with our naked eye. That would include pieces of fecal material, pieces of toilet paper, and things that are attached to this fecal material and toilet paper, probably microbes. The microbes have already begun to digest this fecal material. So we have fecal material. The microbes have latched onto it. They begin to just digest the waste. Now, some of those microbes that are digesting this waste are pathogenic organisms. We call this step of wastewater treatment primary treatment. Primary treatment is a step where we remove the large-sized organic material from our wastewater stream. Primary treatment is really a pretty simple system. You'll see some pictures in a few moments. But basically, we rely on the wastewater to go into a large tank, and over time, the large-sized organic matter will settle to the bottom of the tank, thanks to gravity, and then we can remove it. That's step 2, primary treatment, which we'll spend some time on in just a few minutes. Then we remove the organic matter that is smaller in size. We say it's colloidal organic matter. And that's because we can't see it directly with our naked eye, and gravity will not settle it out. So we have to use another step to take out the small-sized organic material. Some of it's colloidal, some of it's actually dissolved. It's the same types of waste that we see in the large-sized particulate organic material, but it's smaller in size. It won't settle out in water, so we can't use gravity. Gravity is the easy way. We use gravity in preliminary treatment and primary treatment, but now we have to use something else to take this out. And we'll talk about that. And the fourth step in wastewater treatment is to remove any dissolved inorganic material from the water. And that would include nutrients like nitrogen, phosphorus, potassium that come out of human excretory wastes, phosphates from detergents. We need to remove that from the water, and that's called tertiary treatment. Okay, let's go back. What else might we have in raw sewage in a community? Some communities will remove other things also. So, for instance, in addition to the previously mentioned 4 categories where we remove the debris and grit, the large-sized particulate organic matter, the colloidal organic matter, and the dissolved inorganic matter, we might have a treatment to remove pesticides, maybe to remove heavy metals, or maybe to remove other toxic compounds, depending on the manufacturing processes that are prevalent in the local community. So if we take a look at the steps in wastewater treatment, a wastewater treatment plant should remove all 4 types of pollutants that we've talked about for complete treatment. Wastewater treatment plant removes these 4 types of waste products in a sequential step system. And then we add chlorine to the water, and the chlorine basically kills the pathogens. So if you've removed the debris and grit, the particulate organic matter, the colloidal organic matter, the inorganic dissolved nutrients, and you chlorinate the water to kill the pathogens, that water is good enough to be put back in this river or stream, and it will not cause harm to organisms or the public that comes into contact with it. So here's our wastewater treatment plant. We'll go through some of the steps. Wastewater comes into the wastewater treatment plant as raw sewage. Remember, raw sewage is 1,000 parts water to 1 part waste. It goes through the bar screens to remove the debris and grit. It eventually goes to primary treatment, secondary treatment, tertiary treatment, undergoes chlorination or another treatment that will kill the pathogens, and the water is put back into the stream. So we basically have 4 wastewater treatment steps, and they include, they're very sequential steps. Preliminary treatment, where we remove the debris and the grit. Then we have primary treatment, and that's where we remove the large-sized organic materials. And then we move to secondary treatment, where we remove the small-sized organic material, the colloidal organic matter, the material that's too small for gravity to take out of the system. And then we remove the dissolved organic material, which we call tertiary treatment. So basically, sewage treatment generally involves 3 or 4 steps. A preliminary step, which you're not seeing here, the primary treatment step, the secondary treatment step, and the tertiary treatment step. And these steps basically will clean wastewater up to the point where it's okay. Secondary treatment is not a physical step. This is where we remove the colloidal-sized organic material. And basically, we do that by making microbes work for us. The microbes basically degrade the colloidal organic material. And then we have that other step, tertiary treatment, where we have specific processes that can remove nitrogen, such as denitrification, a specific process that could take phosphorus out of the water, a specific process that can take salts out of the water. So after we've gone through preliminary, primary, secondary, and tertiary treatment in an ideal wastewater treatment plant, then we make sure that all the pathogens are dead. We chlorinate the water, or we use another process that will kill the pathogens, such as ultraviolet radiation, and that will kill the pathogens, or maybe ozone, which will kill the pathogens, and then we return the water to the river. So again, if we look at the wastewater treatment steps, we have preliminary and primary treatment. They're physical processes. We depend on gravity to take these wastes out of water. Very simple. Then we have to go to secondary treatment to remove the smallest sized organic material. Gravity won't do that for us, so we have to use microbes. And the microbes will dissolve or basically break down the colloidal organic matter. So we call secondary treatment basically a biological treatment step. Today in the United States, 98% of cities have wastewater treatment plants that will treat waste, liquid waste, through secondary treatment. Preliminary, primary, secondary, and then killing the pathogens. When the Clean Water Act was written, it wasn't mandatory to take out the dissolved inorganic nutrients such as nitrogen, phosphorus, and dissolved salts. However, increasing numbers of wastewater treatment plants are installing some sort of tertiary treatment to remove phosphates, nitrates, or both of them. If we look at our region, in the Pacific Northwest, all cities treat wastewater through secondary treatment. Many cities have installed tertiary treatment to remove one or more inorganic nutrients. Phosphorus is the most common inorganic nutrient that is removed in tertiary treatment here in the Pacific Northwest. Okay, so we're going to go through the steps sequentially now. We'll take a look at preliminary and primary in this lecture, and in the next lecture we'll go into depth and talk about secondary, tertiary, and killing pathogens. Okay, remember the sewage arrives, the wastewater arrives from the community to the wastewater treatment plant. The first thing that happens, it comes into the wastewater treatment plant and we remove the debris and the grit. We call it preliminary treatment. This is the first thing that happens, or the first thing that's removed, because the debris and grit is large and it can damage or clog other pumps that are used in the wastewater treatment plant that are used to move the wastewater along the line. Preliminary treatment, the raw sewage flows through what we call a bar screen. The bars are 1 inch apart. I mentioned them before. I'm showing you preliminary treatment again. Here's the liquid waste coming in from the sanitary sewer. It comes in the wastewater treatment plant and it flows through a bar screen. Anything larger than 1 inch in diameter is retained by the bar screen, and then that material, which doesn't go through the bars, is scraped off, and it's either incinerated or landfilled. The water that goes through the bar screen then goes to a grit settling tank, and here the water sits motionless for a few moments, and anything very large will settle to the bottom, and that's removed. So in preliminary treatment, the debris that is captured by the bar screen is raked off and incinerated or put in the landfill. After the water flows through the bar screen, the sewage then flows through what we call a grit settling tank, and this is where the velocity of the water slows, slows, and that lets out that lets sands and gravels, which are less than an inch in diameter, to settle out. And when they settle out, they can be raked off the bottom of the tank and then disposed of again by either incineration or sending it to a landfill. So again, here we have preliminary treatment, the bar screen here, grit settling tank here. You remove this debris and grit, get rid of it. Very simple step, very effective step, but it gets rid of a lot of waste. So the grit is commonly removed from the bottom of the grit settling tank, and it's buried in landfills. Often it can be incinerated, but it's usually buried in landfills. Okay, we've removed the big stuff. Then we go to the second step of the wastewater treatment plant that we call primary treatment. This is where we remove the large-sized organic materials. And we call it particulate organic material because we can actually see it. So primary treatment basically is pretty a simple system. And just by gravity, we can remove 30 to 50% of all the organic matter in that wastewater stream. It settles to the bottom, we remove it. Some other things happen in this tank. There are things that are lighter than water. There are fats, there are oils that have entered the wastewater stream from people's kitchens. They slowly float to the top of the tank. And then they can be removed. They can be skimmed off the surface. So here we have a primary treatment system. Basically, the large-sized organic matter has settled to the bottom by gravity, and the fats and the oils have floated to the top, and they can be skimmed off. So we can remove the organic material from the bottom. We can remove the fats, oils, waxes that are lighter than water from the top, and we basically created, removed sludge from the wastewater treatment plant. Again, here's another diagram of primary treatment. So let's go back to see where we started here. And preliminary treatment. Wastewater comes into the wastewater treatment plant. It goes through the bar screen, and then it goes through the grit settling tank. And basically, we've removed the large-sized inert materials. Then we move to primary treatment. We have a primary clarifier tank. The water flows into the tank, and the water sits motionless for hours. By sitting motionless for hours, the larger-sized organic matter has time to settle to the bottom of the tank. In addition, any fats, oils, and waxes that are in the wastewater stream float to the top of the primary clarifier. Well, then we can remove the solids from the bottom, and we can remove the oils, greases, waxes that float to the top. We can skim them off the top. And collectively, this organic material and the oils, greases, fats, waxes that have settled at the top, we remove them. And when we remove them, we call that material raw sludge. Now we can take that raw sludge and we can do several things with it. We can bury it, we can incinerate it, or we can process that raw sludge into an organic material that we can use as a fertilizer or a humus. Again, preliminary treatment's pretty straightforward. Again, primary treatment, we're removing the large inert particles. We move to primary treatment, where the large-sized organic matter settles to the bottom of the tank. The light greases, oils, fats, waxes go to the surface. We remove them. So the removed material can be incinerated again, it can be landfilled, or it can be processed into an organic fertilizer through a process of anaerobic digestion or composting, which we'll talk about a little bit later. So those are the first two steps in wastewater treatment. We'll talk about secondary treatment, tertiary treatment, and basically disinfection of the water to kill pathogens in our next lecture. Thank you for your attention. You rely on gravity. The sewage flows through large tanks that are called primary clarifiers. The water sits motionless for hours. As the water sits motionless, the large-sized organic material slowly settles. Humans as sewage. In the last 20 years, we've more commonly used the word wastewater. So remember, sewage treatment is equal to wastewater treatment.